But while I will be talking, I will request Dr. Zambakaitis from South Africa. He's just here. He will be joining us on the stage. Dr. George Thomas is here. Dr. George Thomas is not here. Okay, he will be joining us. So, what we do is we have a scientific program pretty hectic during this one day. Initially, we had planned for 1.5 days to 2 days, but because of
Hello?
Yes, sorry, I was a call from India, so I had to take my father. Was just being okay. So it's okay now. The mic is working. So may I request Professor Dr. Zambakaitis to please join us on the stage for the small speech. And I was just telling you that we have been doing this course for the last 7 years, 5-6 years now, and we'll have a pretty hectic scientific program. We have 5 live transmissions. Planned 2 from Bombay, 1 from Pune, 1 from Nashik, 1 from Freiburg, which is a university in near Lausanne. So we'll keep you occupied during the whole day. Okay. Okay, he's trying to find the correct distance. Okay. So we'll keep you preoccupied. We have 2 coffee breaks, 1 lunch break. We'll try to finish by 6 p.m. We will have Professor Singvert possibly not being able to join us because of some ticketing issues. Who was supposed to give a lecture. So first of all, we'll start the transmission from Bombay. But before that, I would like Professor Cribier to put a small word as a welcome speech in this meeting.
Good morning to all of you. It's a pleasure for me to be here again. It's the 5th year. Number 5. So I used to join you for this meeting, which has been always very interesting, with a nice program of interventional cardiology and cardiology in general. I don't know how many of you are interventional cardiologists, or if any are you interventional cardiologists? Do we have some interventional cardiologists?
Yes, obviously. Yes. He's just asking that how many do we of this program? We are mostly clinical cardiologists, they are all MD medicines, but not many are interventional cardiologists. So we have to design the program so that we can tell them in a way so that they understand in a more better way.
Okay, fine. So we try to teach you a few things about interventional cardiology as it is done today, and especially on coronary artery disease and aortic valve stenosis. And I hope that you will have a full good day, and again, it's a pleasure for me to be here with you. So I think we have to
keep ready for questions. Okay, so may I request Dr. Zambakaitis to say a few words. He's come all the way from South Africa, and we wanted to have 2 people actually from South Africa. Professor Sarki and Andrew could not come and because of some issues, but he will be representing his country. And I would like you to introduce yourself a little and then tell about his country, and then for 3-4 minutes, and then we'll go for the live session.
Yeah, well, it's a pleasure to be here. It's my first time attending this meeting, and we've heard a lot about it. And we hope we'll be able to show you what as interventionists we do. I'm an interventional cardiologist in the largest public hospital in South Africa, Baragwanath Hospital. And I'll just show a few interesting cases as well at one or 2 of my talks. But hopefully it'll be nice, interesting, and interactive. Thank you.
You could have done the IP to some extent before this complete.
So we'll have a live transmission from by Dr. Rajiv Bhagwat from Bombay, and we'd like to get connected. We are already ready in the cath lab, so it takes about a few minutes sometime to get connected by internet lines, and hopefully it will be done quickly. Hello? Hello? Yes? Yeah. We are waiting for you because we are waiting for you to be connected. Can you dial us? Can you dial us? Okay. We are absolutely ready for you. They are dialing actually.
Okay.
Dr. Josh Thomas is here.
If I sit down there, no, can they hear us? That's
No, this is not. This is just a hospital.
This is you ask that number. Pass that number.
This is Dr. Shreda's actually. He will give an action. Just now, are you ready? No, we don't want this now. They are waiting for the catheter.
We've got to speak to me. Speak through it.
Excuse me, is it just one hospital?
Yes, please. This is
Yeah,
Dr. Ashwin Mehta.
actually we need your IP number.
I will just have to wait till I dial through now. Okay, okay. Tony, they are dialing again and again. Please disconnect this one. We don't want this now.
I did it. They tried, but
Okay, so actually they were dialing. Yeah, so we disconnect.
You're recording here? Sorry.
It will be good opportunity while they are connecting.
Okay. I'm not from the hood. Perhaps
You're waiting.
inside. Yeah, up there, and I need to.
this is the thing before. Kick him out again.
Which one? This is which one?
This is the one that
They're coming in.
they're coming in. They're coming in.
Just prove the IP number.
Hello. I'm from Jasper Hospital, Dr. Ashwin Mehta's assistant.
Okay.
Hello.
Good morning.
Current.
Yeah. Good morning.
Yeah.
We would like to give you our IP number.
Yeah, please give it.
Please note it down. 115.
Okay.
Okay.
That should be fine.
Point dot 249
Okay.
dot 183
Okay.
dot 41.
Okay. I repeat it. Please reconfirm it. Is it 115.249.183.41, right? Now we can go to this.
Tony, please dial from this side so that, or they're dialing again and again. We're waiting. The cath lab is waiting.
You don't call, nobody calls. No. Nobody calls. I tried this number. Say no connection. I tried it manually. No, they try again. I kick him out.
Just tell them we don't want them now.
Sorry. Sorry. I think I've got another plug here, so maybe unplug me and I'll
Hello.
plug
Yeah.
in
Can
here,
you confirm the
which will be
number
easier.
again?
Yeah, no, it's okay.
Thanks.
Yeah.
Just I'm reconfirming the number again.
Please.
115
Give me the
Yeah.
other part.
dot 249
Yeah.
dot 183
Yeah.
dot 41.
This one. Thanks.
That's right.
Okay, but now just we are disconnecting from your side because we have to move to another site in Mumbai, and we will be coming back to with you in an hour or so. Okay?
in an hour.
Maybe another couple of hours. Thank you.
Thank you so much.
I'm sorry for sometimes this is miscommunication. We should have an Indian technician also here, so if you want it. He's trying his best this morning. So let me have a small, if you don't mind, can we have, till the time they're connected, can we have some introduction by the people who are here, just by the names. You should tell, what do you say?
We can introduce the topics in there.
Okay. So as I told you that first of all we'll have a transmission from Bombay. I think there's some problem. Are they getting connected or not? Because they're desperately waiting for the connection. Tony, can you dial them?
I tried it. It says this number is invalid. The number you wrote down is invalid. I tried it.
Can we have the lecture, sir? Sir, we can have it.
This is the number.
Yeah? Dial.
I tried. No. Not possible. The number is not valid. The IP they gave us is not valid.
Recheck the room.
Ravi, just try to contact him.
Is the number correct IP?
रुपए कितने देके आएगा बर्बादी करते
Can we start the lecture in the meantime? Ravi, can we start the lecture? Just be with us for 5 minutes. Yeah? It's very important. Dr. Rajiv Bhargava from Bombay, Shubha Hospital, is already waiting. Just catch that. I think you stole. I think you're wrong. Tony, he's dialing now again. He's constantly dialing.
Okay.
Don't dial. Let them dial. Of course, they have it. Connections are on.
It's waiting. So it shows me when it comes in.
What we can do, we can have lecture by Prof Cribier now. Sir, he's waiting, yeah. He's waiting. I think so. We have solved this thing. They will wait for 1 hour.
Yes, well, I am ready.
No, I'm sure it will. No, but there's only crossing about now.
That's why I put it down.
Yeah, maybe on the corner there, but it's safer. So
We will start, Professor Cribier, they will wait for 1 hour or 45 minutes. We'll start your lecture because there is some technical problem there. Because it was very clear in the morning when I said correction. So this will be a very important lecture. So I'm sorry for the delay, but this is always happens in the early part of the morning. Professor Cribier will be talking about the percutaneous valve replacement or implantation, which is a new technology, especially for the aortic valve disease. He has been the innovator, the pioneer. Let me introduce him once again. He was the first person in the world to do aortic valvuloplasty in 1986, which was published in Lancet at that time. After that, he has done a lot of work in the mitral mastectomy. And recently, or now, he was the first person to do a first transcatheter aortic valve implantation. You know, the aortic valve disease, especially in elderly patients, require aortic valve replacement if the patient has a critical aortic stenosis. So these patients, especially those who are elderly, having a comorbid situation like bypass surgery, renal failure, they are most of the time declined by the surgeons. And we know that aortic valve disease is such a disease where if you have a critical aortic stenosis, the patient goes into LV dysfunction, and once they have LV dysfunction, they rapidly decline to the death. And for so many years, this technology was being tried. I'm talking of 1997, 98. It was in experimental models. At that time, he was a person who was doing a lot of experiments in pigs in Paris. He had an idea. It was taken up by the companies. Initially, there were 2-3 companies, BVT, and then Edwards came in. In 2002, he did the first human implantation of the aortic valve, non-surgical. This is called percutaneous. Means you're not opening the chest, you're going through the groin, just like another balloon angioplasty. You put a balloon, you dilate the valve, put a valve which has been created and designed by him. So he is a So we are very blessed that he is here to tell about this historical aspect, show you a small film about this, how the technique is done, because this looks simple, it's not so simple, putting a valve without opening the chest through the groin from the aorta, then placing it well and it does not move because there are coronary arteries which are there. So it is a very important technique, and more than 55,000 patients all over the world have received this technology. Unfortunately, for our country and other Southeast Asians, it's still not available in India. For the reasons which is not yet clear by DCGI. It is actually approved in Europe. It is accredited by the FDA in US. So this percutaneous valve replacement has been the most important innovation of this 2000 millennium, post-millennium decade. So this will be one of the most important lecture, and he has received a lot of awards for this. He was by TCT, he was given the best lifetime achievement award I think 2 years back. He has been honored by various societies in France. He got a Legion of Honor, which is like Padma Vibhushan, in India by the French government recently, last year. The 10th anniversary of the aortic valve replacement has been recently celebrated in France, because he did the first in 2002, now it is 2012. The 16th April was the first valve which was done by him, 2002, and now 2012 in April and May they had celebrated the 10th anniversary of this. I think soon we will have it in India once we have a clearance from the DCGI, Drug Controller Government of India. The reasons are best known to the government why this is still not available. Once you're ready, let me know. Yes. Okay. So why it is not yet available? Cost-wise, we recently did 2 patients from India, 2 from Bombay and 1 from Delhi. We took the patient to France. It is at his place in Rouen, and the procedure time is hardly 45 minutes to 1 hour. The patient is again it's not sedated. The patient is of course fully conscious, and US is still they are doing in under anesthesia, but in France and other part of the country, especially in Europe, they are doing in a conscious patient just like another balloon angioplasty and putting the stent. Are you ready? Okay, so let me give a clap to him for his years and for his such a noble work which he has been doing. And let me tell you that he's also coming up with a new percutaneous mitral valve, which will be a big discovery, and maybe after 2 years we'll listen to his lecture on this.
This is not ordered.
Can you connect with this technical part?
Again, good morning.
I'm
very pleased to be with you, and I will try to explain to you what we are doing today for replacing the aortic valve. So you know everything about aortic valve stenosis. In India, it's more or less rheumatic in origin. In Europe, in the United States, mainly degenerative. So we have a number of patients who should be operated on for a surgical aortic valve replacement. They cannot be operated on for many reasons. It's a number of patients, and for them I have developed some techniques like Vivek told you about aortic valvuloplasty, and then the replacement of the aortic valve without opening the chest by introducing the valve through the femoral artery. So we will start here. We are now reaching 10 years from the very first case of aortic valve implantation without surgery. So this was a very big thing. And you see here that we had in my department, in my hospital in France, more than 600 attendees coming from 50 different countries. All the people who were in the room had been trained and are also using this new technology for implanting the aortic valve using non-surgical techniques. So it was a very, very great moment. And I will just tell you a few things about this. You know, first of all, when you think about replacing the aortic valve without opening the chest, it's difficult to get approved by the experts, especially by the surgeons. So in 2000, at that time I was doing some animal experiment, and I was showing the first results of implanting the valve using a non-surgical technique in the sheep model. And this was the opinion of the experts. You know, I was considered a crazy, reckless idiot, that I will never get funded to develop this technology. It could not work and will kill the patient. In 2002, this was the birth of the technique. I did the very first case. It was a big event in all American meetings, European meetings. I showed the first patient with a valve implanted without surgery, and the experts said at that time that it was the most stupid project ever heard. In 2005, we had a number of patients done in France and abroad, and each time when we were showing the results of these implantations, this was a reflection, this was the opinion of the experts, that all of us were merely irresponsible. The procedure was too complicated, and basically it could be used only for very inoperable patients. And finally, in 2010, the opinion of the experts have totally changed. We are visionary, breakthrough procedure which is easily generalizable. It's better than sex. We transform therapy for most aortic stenosis patients. So this is the last opinion of experts concerning this technology. So on this slide, you will show from where we started and where we are today. First of all, in '85, for those patients who could not have the valve replaced surgically, I developed balloon aortic valvuloplasty, which consists in inflating a balloon across the aortic valve in those patients just to improve them a little. And this was done everywhere in the world. Tens and tens of thousands of cases were done, including India. I dilated patients in many places in India, and this technique is applied on a regular basis in India for those patients who cannot have the valve replaced. Unfortunately, this technique is associated with restenosis. It means that you dilate the valve, and after 1 year or 2 years, the valve is back to the same situation, you know, very tight stenosis, a lot of calcium. And so I had to find a solution against this restenosis issue. So in '94, I tried to develop a stented valve. It means that instead of dilating the valve with a balloon, I wanted to introduce a stent inside the valve, inflate the stent, you know what is a stent, like we use for the coronary arteries, but a big size, with leaflets, valve leaflets inside the stent to maintain the valve open. So I did a number of sheep in Paris. And then between '94 and '99, I tried to find a company interested in developing this technology, but it was a complete failure because nobody believed that it was possible. So finally, we created a startup with Martin Leon, who is a great cardiologist in the United States, and 2 engineers, and we created a company named Percutaneous Valve Technology. And from this company, we got some prototypes of valve. Then we moved to animal implantation, and in 2002, 10 years ago, we did the first case in human. Then started a period of studies using this technology in human, in France, and in some other countries in Europe. And in 2004, finally, the company was acquired by a company that maybe you heard, Edwards Life Sciences, which is a company based in the United States and who has the most beautiful experience in creating bioprosthesis, surgical bioprosthesis. So they acquired the company and they developed the device, and they sponsored a number of international transfemoral and transapical feasibility studies in the world. And finally, the device was marked, CE mark approved by the European Community in 2007 and started post-market registries. Finally, in 2008, started a very, very important study in the United States that we call the Edwards Partner US Pivotal Study, randomizing patients with this valve against the surgical valve. And finally, in October 2011, this technique was approved by the FDA for patients who are non-surgical candidate. And in 2012, it's last October, finally the technique was approved by the FDA for all patients who have some additional risk for surgery. So it's a big adventure, as you can see here. So I developed this device, we got this FDA approval, which is extremely important, of course. And at the same time, there is another valve that maybe you heard, which is called the core valve, which is totally different of the valve that I have been developing, who also came on the market with the first man in 2004, and finally doing today the ongoing US pivotal study in order to get approved by the FDA. So more or less, we have two devices. But you see that the development of this technology was a very long road, 25 years from the first-in-man case of balloon aortic valvuloplasty, 18 years from the concept of a standard valve, and 10 years from the very first case of the valve implantation. So today, all the experience with the non-surgical implantation of the aortic valve has been obtained with this valve, the valve that I have been developing myself, which is a balloon expandable valve. So you have a balloon inside. I will show you the way it works. And with this other valve, the core valve, and we have today, it's not 60,000 valves implanted worldwide, but we are reaching almost 100,000 valves implanted in more than 500 centers out of the United States. I think you have started in India to implant in a few places, and 150 centers in the United States. So you see that it's quite successful. And you see here the growth of this implantation procedure since 2010. And this is the way it works. You know, we have this line, we are using today this procedure in so many patients. For example, in France, we have 600 valves implanted each month. So it means that it's something very, very important. So why did we develop this technology? It's very simple. When you have a patient suffering from aortic valve stenosis, we have the only possible treatment, as you know, is to replace the valve surgically. And the surgery, aortic valve replacement, is extremely efficient. As you know, you have probably many patients who have the valve replaced surgically, but unfortunately, in many cases, surgery cannot be done. And many reasons not to have the valve replaced surgically. We have, here the European Heart Survey in 2004, showing that if you take all the patients with aortic stenosis, no operation is observed in more than 1/3 of the cases. So it's a number of patients. In India, it may be worse of that, because sometimes the patients do refuse to have the chest open. And so I think that in India, patients with aortic stenosis would be excellent candidates for having the valve replaced non-surgically. So this is just a slide to show you what we did post-mortem, autopsy specimens in the 93, and during 1 year. We get an autopsy of patients who died of aortic stenosis. You can recognize here an aortic valve with a lot of fibrosis and calcification. And this is the results of balloon aortic valvuloplasty. When you introduce a balloon to dilate this valve, you can fracture one of the leaflets. And so then the valve is getting a little more supple, can open a little better. And unfortunately, these results don't last for more than 1 year, 1.5 years. In opposition, if you put a stent inside the valve, you can see here that we have a very wide opening. Maybe can you observe here the struts of the stents pushing aside the calcific leaflets. And then the most important part of the observation is to cut the aorta longitudinally. And this is what we have here. You have the aortic valve inside the aorta. The aorta is here, the left ventricle is there. And doing this experiment, I could determine, the characteristics of the stent that could maintain the valve open without occluding the coronary arteries, which are here, without contacting the mitral valve, which is very close from the aortic valve annulus, which is here, so we cannot accept, to have a contact of the stent with the mitral valve, and without pushing some pressure, contacting the intraventricular septum, because you know that inside the intraventricular septum is bundle, and we can create a permanent block. So from this post-mortem experiment, I decided that the height of the stent that would be implanted inside the aortic valve should be in the range of 14 to 16 millimeter in the human being, and the diameter of the stent should be in the range of 23 millimeters. So this is what I had in mind. And when the stent was implanted at that site, it was almost impossible to dislodge it. So the risk of having the stent embolizing in the aorta was extremely small. So then we created with the percutaneous valve technology, our startup company, this valve. You see here that the valve does correspond exactly to what I had in mind. So this is a stent, a stainless steel stent, and inside the stent we had placed 3 leaflets looking like a normal aortic valve. And you see that in the bench, when we put the valve in the bench, the valve was opening and closing quite normally. So this was reproducing actually a normal aortic valve. Of course, the first model valves were made of polyurethane. It means that it was not a biologic valve, it was something, an artificial valve, but not made of the pericardium or whatsoever. So very rapidly we moved to bovine pericardium. So this is the very first valve that we implanted in human. You can see here a stent, which is a little sophisticated, with 3 small leaflets inside, reproducing a normal aortic valve. And this stent valve can be crimped over a balloon, a catheter. As you see, we can crimp it very solidly, and it cannot move when it is crimped. And the crimping was done in such a way that the stent was not destroyed and the valve was not destroyed as well. And so we used at that time a Numet balloon, which is a commercially available balloon, and we placed the valve just across the balloon. And using this device, we could implant the valve in more than 100 sheep. It was a very long experimental studies, and we did acute results and long-term results. So finally, in April 16th of 2002, we had the very first clinical case in my department. This patient was a 57-year-old man who came to us in cardiogenic shock, so he was absolutely dying. He had almost no heart contractility. As you can see here, the ejection fraction was only 12%. He had multiple comorbidities and he could not be operated on. And also, he had an aortofemoral bypass on both sides, both occluded. And so for these patients, we had to implant the valve to use what we call the Trans-Septal Approach, which is not the easiest way to get to the aortic valve. You see here the very first case, so the valve was pushed from the femoral vein, crossing the intra-atrial septum, and then making this U-turn in the left ventricle to finally reach the aortic valve, which is here. So you see that we were very concentrated for this very first patient, and one of the most important parts, was to place the valve exactly where we wanted, coming from this long route from the femoral vein. And you see here the eyes of the people doing the very first valve implantation. It was crucial, to place the stent exactly at the level of the calcium that we could see on fluoroscopy here. And at the end of this, we had an unbelievable result. You see here that immediately when the valve was placed, the gradient between the left ventricle and the aorta came to 0, and the improvement of the patient was absolutely spectacular. So this is the very first patient. He had several episodes of cardiac arrest before entering into the cath lab. He was really dying, and this is 30 minutes post-implantation, and there is a real, true resuscitation. 8 days later, he is absolutely fresh. He was able to give interviews in the medias, TVs, and he was spending all the days, giving interviews. And from this very first case, we got an important lessons. First of all, we demonstrated that implanting an aortic valve, that means transfemoral aortic valve implantation, so it was possible to implant the valve non-surgically at the level of the diseased aortic valve. But the valve, when in place, was not embolizing, that we had no coronary occlusion, no mitral regurgitation, no permanent AV block, and there was no leak on the side of the valve. We got an optimal valvular function, immediate hemodynamic and clinical improvement. So it was a very big result, and I can tell you that in the world it was a very big story. So then we started a series of patients doing exactly the same, and we could do at the what we call the airway period, we could do a series of 40 patients in my department, all compassionate, all patients dying like the first one, and we are using the same technique. You see here that we are pushing the stented valve inside the tube, which is introduced in the femoral vein here, and we are pushing a guide wire all the way across the heart, exiting the wire from the femoral artery on the other side to get a very strong rail. You can see here the guide wire coming from the femoral vein, crossing the intra-atrial septum, doing this sharp U-turn in the left ventricle to finally place the valve at the level of the native diseased valve. And this is what we are doing with this mother valve. And after 2-3 patients, we decided that we could improve the device, and we moved from this bovine pericardium valve to this one, which is quite sophisticated. You can see the stent here, which has been specially conceived to receive the aortic valve. We have 3 leaflets made of equine pericardium, so this is coming from the horse. This was for industrial reasons, and we were quite successful. We had 85% of success of implantation. In 2004, the concept was acquired by Edwards Life Sciences, and they improved a little things. So from this valve, which was the valve that I was using in the first examination, they moved to this one that they called Edwards Sapien valve. So if you have read a few things about this technology in the literature, you have heard of Edwards Sapien, and they made the valve with 2 different sizes, 23mm and 26mm, and the valve was able to be implanted from the femoral artery, this time, not from the femoral vein, from the femoral artery, going through the aorta and finally implanted at that level, and also through the apex of the left ventricle, which is what we call the Trans-Septal Approach, by the surgeons. This is, I don't know what happened, I'm absolutely sorry. Did you do something to the, are you connected or no?
They're dialing now. You just connect and hold.
So I disconnect
No,
him?
don't disconnect. Without disconnecting, you connect them and hold.
Okay. He makes it automatically. Let it off.
What do you mean? Accept that. They're dialing it.
And they make it come along. When he calls, it accepts finally.
So we were disconnected for any reason.
हेलो अब वो कह रहा है कि अब ऑटोमेटिक लेना चाहिए तो ऑटोमेटिक ले नहीं रहा. You have to accept it. No?
They make it automatically. If nobody is inside, we have somebody in the line.
Yeah, they're already dialing. They're dialing, you accept it.
Okay. It looks like that. If somebody's in the line, we can't call. I know if somebody did call right now, meanwhile,
Just talk to them. Just